What's up, everybody? I am here. I am just on mute for the most part for the next 4 minutes. We will pop the camera on in 4 minutes and start the lesson. If you have any questions for me in the meantime, hit me up in chat. I will try to get back to you. Talk soon. Are we here? Did we make it? Welcome to free Gmat Prep Hour, January 24th, 2021. I am very happy to be spending an hour with you all today. Getting some good general questions in chat. Good question that I think maybe lots of people could learn from here. Just came in from Eugene. What is good advice for someone just starting out their studies with the Gmats? I think one of the first things I would do is get some official materials, get the official guide. Never far from my official guide. Get some official practice materials because those are the best sources for questions. You will definitely want to utilize those on your journey. The other thing I would do early on is take a practice exam. Now, you don't have to necessarily take an official practice exam because those are not infinite. There are only a handful of those, and maybe you don't want to use one up this early in your studies, but take some practice exam. Manhattan Prep has free practice exams. Go for that. Other options too. Just so you can kind of see what your baseline is. But maybe before you take your first practice exam, do a little reading on Gmat Basics. What is data sufficiency? What is your goal in sentence correction? These things, just so you're not going into the exam 100% blind. So that would be one of the first things I would suggest to do. Yeah. All right. So I see people are asking me questions in the Q&A. I see people asking me questions in chat. I'm going to go ahead and just say, if you have questions, hit me up in chat. The Q&A and chat gets a little unwieldy. So just hit me up in chat. If you want to ask questions more discreetly, just send a message to the panelists. Okay, so what are we doing today? Well, what we're going to do today is we are going to talk about quant topics, but through the lens of taking notes. So we are going to spend some time today talking about how to create flashcards, why to create flashcards, what goes on the flashcards, some of the resources we have online for creating these things. And I'm going to use problems that a handful of you have sent me as inspiration for these. Before this starts, these are good jokes. Important question that just came in. Can we expect any structural changes to the GMAT in 2021? Structural changes. I don't think they're going to get rid of the quant section. I don't think there's going to be major structural changes like that. I don't think we often don't know until they actually come out with specific news, but I don't hear of any foreshadowing behind changing the structure of the exam that much. Important news that just came out though in the last couple of days is that the GMAT Online is apparently here to stay forever. Yes, the GMAT Online is here to stay forever. So if you thought it was going to leave at the end of February, I'm sorry, or I'm glad to tell you that it's still here and it will be here for the rest of our lives. All right, so what we're going to cover today, flashcards, why to take them, what goes on them, and where to kind of create these maybe in some online resources. So the first thing I want to address here is why you should create flashcards. So much of the GMAT and our success on the GMAT is predicated on knowing how to tackle questions in a relatively short amount of time. And flashcards can help kind of cut down on the time it takes to determine what to do, or just, how to better look at an expression, whether that's in quantitative language or in English. Okay, so today we're going to focus on quant, although I might do another one of these later for, sentence correction in particular. What we're going to do mostly today is look at some problems, and then if we're having trouble with the problems, figure out how we can create flashcards that drill those kind of sketchy areas in the problems. And then I want to walk you through one example of an app or a program where you can create these flashcards. So what we're going to do first is start off with the problem. I'm going to give you, I don't know, about a minute or so to think through this. And while you're thinking through this, I'm going to answer some questions in chat. So I'll start the timer for a minute. When you have an answer, hit me up privately with an answer. It's been 30 seconds. Thank you for sending me all these answers in chat, getting lots of them. Excellent. All right, that's been about a minute. Now, of course, on the actual exam, you have an average of 2 minutes per problem. But I think a question like this really benefits from knowing how to do it quickly and how to proceed with confidence. So we're going to read this down. A sweater is originally priced at $45.35, and it's discounted by 40%. We need to figure out the new price of the sweater. So there's a handful of ways to proceed in a problem like this, but I think we want to find efficient, repeatable processes for questions like this, because you're never going to see this exact question on the exam, but you will see ones that are very, very similar to this, or at least components of the question involve language just like this. So on this question, what I'm going to do is I'm going to take a look at the answers on problem solving. Make sure you're looking at the answer choices. You might see here that the answers are kind of ugly, right? Dollars and cents, very, very specific. And they're also kind of pretty spread apart. Like answer A is exactly half of answer E. That might be something to notice. And with the answers this far apart and this kind of, I don't know, ugly looking, hyper specific, one thing we might consider doing is just estimating. Okay, so one thing we can do here is, oh, Tyler, I like that point. One thing we could do here is just figure out that if it's discounted by 40%, well, it's not half off, right? It's the majority of the price is still there. And so we know any answer that's less than half of 45.35 is going to be incorrect. And that could be an easy way to filter out anything below, I don't know, $22.50. So these are things to recognize, even if you already clearly know how to do this problem, recognizing what the answer choices afford us. How I would solve this problem looks something like this. I know that if I discount something by 40%, it means, well, 60% of the original price is still there. So I'm going to figure out 60% of the original price, or 60% of 45.35. Now, when I see a percent of, and it's a percentage that is, I don't know, kind of a nice percentage, right, a round number, the thing I want to do here is convert the percentage to a fraction, all right? Percent literally means over 100. 60 over 100 is the same as 3/5. So I'm going to think about this problem as 3/5 of 45.35. Now, you could actually solve 3/5 of 45.35, or you could kind of remember back to this idea of estimating or approximating. This is going to be pretty close to 3/5 of $45. And from there, this problem might get even easier. That's 3 times 1/5 of $45. And so by doing these series of steps, we can say, well, 1/5 of $45 is $9, and 3 times 9 is 27. If we look at our answers, there's really only one answer choice that's close to 27, because we know we estimated a little bit by forgetting about this 35 cents, but only answer D is close enough, and this one is indeed answer D. Tyler typed into chat, I think they're trying to trick you with answer A. Can anyone tell us or agree with Tyler? Why is answer A a trap? Yes, good. Farah chimed in, JD, Raj. This is the other the other answer to this problem that might make sense if you just find 40% of $45.35. In other words, these are the evil twins, right? These two answers add up to the total. 1814 is how much the discount is worth. 2721 is how much of the price is left. And on these kind of discount questions, oftentimes, maybe not the majority of the time, but it's fairly common that one of the answers, one of the wrong answers will be the kind of the complement to the right answer. In this case, the value that makes up the whole price when combined with the correct answer. So that could be something to look out for. So there's a handful of things that we could put on flashcards from this question. Let's talk about like flashcards in general, what you can put on. I think flashcards are great for quick facts or definitions or conversions for like fractions to percents and decimals and vice versa. That might be something to put on the flashcards from this question if we didn't really know what 40% or 60% converted to as a fraction. I think the best use of flashcards, though, are these reminders that whenever we see certain language or an expression or symbols of some sort on the page, we think to proceed in a certain way in our solution path, all right? I know a couple prep hours ago, Whit did a prep hour on knowing the code, and she did a lot of these flashcards on when I see this, I'll think this. I think this is probably the best use of flashcards. And to kind of understand or to test yourself on the theory of when you see this, I'll do this. Put that theory into practice by maybe creating some problems that test the triggers. So here's what some flashcards might look like on the problem we just did. If I think of a loss of 40%, I could also still think of that as 60% still there, right? Like think about it as like maybe pessimism versus optimism. You know, we lost 40% of our clients this year. Yeah, but that means 60% stuck around. Something to think about. Common percentages off, common percentages less than or greater than, like 60%, 40%, 25%, 10%. Those common round number percentages are often best thought of as fractions. Okay, and so if we don't feel very good about knowing those fractions quickly, these are some of the factual things you can add to these flashcards, right? If I say 40% as a fraction, I want to know rather immediately that that represents 2/5. If I see 60% as a fraction, I want to know, oh, I could think of that as 3/5. I don't think you can get too good at knowing these conversions, right? They save you time, and the confidence that it builds is worth a lot. Now we can apply these in tougher scenarios. So one type of flashcard you could have here is to say, if I saw this kind of expression, 60% of 45/35, don't necessarily solve for what it is, but consider how you might go about solving, right? How would you simplify that? And so one way you might simplify it is to take 3/5, which is 60%, 3/5 of 45, and 3/5 of 35 cents. If you want to actually drill yourself on smaller, like minute problems, not entire problems from the official guide, but problems that test this, you could say, I want to try solving this rather small problem. And so instead of trying to simplify it, just see if you can get to the answer in your head. And so you could then list the answer, and then you could show, well, this is how I would think through it. This is kind of a great way, or a simpler way of thinking through it. I'll take 1/5 of 35, which is 7. I'll multiply it by 3 to get 3/5 of 35, which is 21. And then I'll have to remember to divide that by 100 because of the decimal point here. Okay. So I want to keep going through some more problems, and I want to keep extracting some potential flashcards we could create based on sticking points in the problems. Let's take a look at this. Oh, I have another one. Oh, I had another one. I didn't even remember that I added this one. Oh, we talked about this earlier. When answers look incredibly specific, such as dollars and cents, maybe we can think about estimating if the math looks really rough. Yeah, and we were able to do that to good effect here. All right, do I have another one? Okay, go ahead and take 2 minutes or so to think through this problem, and then we'll discuss how to do it and maybe some flashcards and takeaways that will allow us to do this more successfully next time. I'll put the clock on for 2 minutes. It's been about a minute. Give you one more. That has been 2 minutes. I'll give you a little bit more time here to think. If you've already got an answer in, maybe we can think of, similar to the last problem, is there a trap answer here? All right, some things to pick out in this problem. I'm going to ignore these gigantic numbers for a second, just because, well, first of all, these gigantic numbers are in themselves a clue. We have no business knowing what 22 to the 43rd power is. Like I typed this into my calculator and it cries. So like, how am I going to know what to do here? I'm going to go ahead and ignore this for a second and get to this other language. Divided by 10 remainder. When you divide something by 10 and there's a remainder, what the GMAT is asking for here is, what is the units digit before you divide it by 10? Let's come up with some examples. Let's do 25 divided by 10. What's the remainder? And then let's do 41 divided by 10. What's the remainder? Right. 25 divided by 10 is, well, you can get 2 entire 10s out of there, and then you'll have 5 left over. So the remainder will be 5. 41 divided by 10, you can get 4 complete 10s out of 41, and then you'll have this leftover 1 just hanging there. So what we see here is when we divide by 10 and we get a remainder, that remainder was the units digit. All right, so this is great for flashcarding. Whenever you see what's the remainder when divided by 10, what that really is asking you is, what is the units digit? So we need to figure out the units digit. Maybe we could just, this is a rephrase. Oftentimes we talk about rephrasing in data sufficiency. We'll just rewrite the question here. In order to find the units digit of this, we need the units digits of each of them. Okay, so if I wanted to find the units digit of 34 minus 23, right? 34 minus 23 is 11, but we can go ahead and just find the units digit by comparing the difference between each of their units digits. 4 minus 3 is 1. Let's try another one. What's the units digit of 562 minus 437? Right, well, it's going to be the same as finding the units digit of 62 minus 37. We don't care about the hundreds place, all right? We only care about the units digits themselves, okay? And so 62 minus 37 would be 25. The units digit is 5. And so we could just put some blanks and then a 5. It only depends on the units digits of our starting amounts. So thinking about that in this problem, I need to find 22 to the 43rd units digit and subtract that from 28 to the 67th units digit. Now, how the heck do we find the units digits for these gigantic numbers? All right, so I'm getting some notes in chat. There are patterns, there are cycles for exponents of integers when it comes to units digits, and that is absolutely correct, okay? When I'm trying to find 22 to the 43rd powers units digit, I actually don't care about the 22, I just care about the 2, okay? Like for example, 2 to the second is 4. 12 to the second is 144. 22 to the second is 484. Guess what? They all have the same units digit because they all originally had the same units digit. If I did this again, if I did 2 to the third, 8, 12 to the third, 1728, 22 to the third, I have no idea what this is, but I know it ends in an 8, okay? Because it only depends on the units digit where you start. So I'm going to think about this more from the perspective of what is 2 to the 43rd? And what is the units digit there? All right, we still don't need to know what 2 to the 43rd power is. We never will, but we need to know the pattern that goes into this. So we're going to go ahead and list the pattern. 2 to the first, 2. 2 to the second, 4. 2 to the third ends in 8. And 2 to the fourth is 16. And I really only care about the 6. Think about what happens when you go to 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, etc. 2 to the 5th is 32, but it ends in 2. If 2 to the 5th ends in 2, 2 to the 6th ends in 4. And so what you're doing here is you're just repeating the 2, 4, 8, 6 pattern that we had here. This is the units digit pattern for powers of 2. All units digits for powers will have a pattern or a cycle. And the nice thing about this is they are only ever 4 units long, 4 values long. Okay, so we'll just show another one. 3 to the first is 3, 3 to the second is 9, 3 to the third ends in 7, 27, 3 to the fourth ends in 1, 81. And you can see that 3 to the fifth, when you multiply something that ends in 1 by 3, it will end in 3 again. So again, the pattern repeats. So now what we want to do is try to use this pattern and say, look, if 2 to the first ends in 2, and I remember that, oh yeah, 2 to the fifth ends in 2, 2, 6, 7, 8, 2 to the ninth ends in 2, right? And these patterns continue. Where will 2 to the 43rd be? Yeah, so the way I like to do these is I like to say, oh, every multiple of 4 power of 2, 2 to the 4th, 2 to the 8th, 2 to the 12th, 2 to the 20th, 2 to the 40th, all of those are going to end in 6. The numbers themselves, I have no idea what they are. They're gigantic. But 2 to the 12th definitely ends in 6, even though I don't know what 2 to the 12th is. So that means 2 to the 40th ends in 6, which means 2 to the 41st would end in 2. 2 to the 42nd would end in 4, and 2 to the 43rd would end in 8. So this is going to be some number that ends in 8. Woo. Once you kind of understand this concept, doing it for the next digit isn't that big a deal. You just have to get started and have faith that the pattern's going to repeat. So we're going to try this for powers of 8. And remember, you only will ever have to do this for the first 4 terms. Sometimes the pattern repeats after 2 terms. Sometimes the pattern repeats after 1 term, like 5 to the first, 5 to the second, 5 to the third. All of those end in 5. 8 to the first is 8. 8 to the second is 64, so it ends in 4. Very good, yes. Some people are catching the trap. 8 to the third will be 64. Something that ends in 4 times 8 will end in 2. 512. And then 8 to the 4th will be, well, something that ends in 2 times 8 will end in 6. 4,096, but we don't care about that. It just ends in 6. And so then we have to do the same thing, figure out, where will the 67th power fall in here? So what I want to do is I just want to go find a multiple of 4 that's somewhat close to 67. I don't know, 60 is good enough. This would be where 8 to the 60th is. A gigantic number again. I just know it ends in 6. That means this is also 8 to the 64th and 8 to the 68th. And if this is where 8 to the 68th is, then this is where 8 to the 67th is. It ends in 2. All right, now we just have to put them together. This is where the last trap can come in. Something that ends in 8 minus something that ends in 2 will be something that ends in 6, but this is the trap. We are subtracting the 8 from the 2, right? If 8 is subtracted from 2, the answer is not 6, right? We need to get the direction correct here. So we have something that ends in 2, and then we're subtracting something that ends in 8. Just test it out. What's 22 minus 18? 4. What's 42 minus 28? 14. You can try this out all you want. This is always going to end in 4, and that means the real answer here is answer C. So this is the other evil twin that we just kind of talked about on the previous problem. This is a pretty intimidating problem. I think at first, right, what we have here is these gigantic numbers, right? 22 to the 43rd power, oh my gosh. 28 to the 67th power, even worse. But these problems, they kind of just foreground that you can't possibly know how to compute these. And so there has to be another way to do it. When you see gigantic bases and gigantic exponents, you typically want to think about these unit digit cycles. This is probably a 700 level question, just because it seems very intimidating. If you don't have enough experience with it, you're going to have a lot of trouble because you're just going to be frozen. Like, I don't know what to do here. This is impossible. But if you've had some experience here and you've reviewed how to do these problems, they're not that tough. Yeah. Just want to check the questions here. Got a question. Austin had a question for me. I'm going to try to get it in my notes. I think the note card will bring it up. This problem I made up. So this problem is not from the official guide. Yeah, all the problems today are Jeff Vollmer specials. So when you see remainder when divided by 10, you need to think units digit. Got to. All right. That is what this is really testing you on. So then try this recognition. When I see this, I'll do this with an example, right? What's the remainder when 34 is divided by 10? Oh, that's just asking me for the units digit of 34. It's 4. When I see gigantic bases, gigantic powers, just know I don't need to determine what those values actually are. Just remember, oh, this is usually a units digit cycle problem. Okay, we don't want to freak out. Remember, the cycles are only ever 4 terms long. All right, so they are solvable. Put those two together in a problem. Try this. What's the remainder when 23 to the 18th power is divided by 10? And see what happens. Question just came into chat. Is this a good strategy, right? To follow the problem we just did with like relevant problems. I think it's a really good strategy to try making your own simple problems about the concept you just did. When you create your own problems, you end up kind of tackling the content and the concepts from the other side, and that creates for kind of more thorough understanding. Yeah. So what's the remainder when this is divided by 10? That's just really asking me for the units digit. Remember, the units digit does not depend on the 20 part of the 3, it's just the 3. 3 to the 18th, I'll just need to figure out this pattern here. So let's just go ahead and get started, unless you remember it from being on the board earlier. The pattern here is 3, 9, something with a 7, something with a 1. And then it repeats. 3 to the 18th, where would that fall? Well, 3 to the 4th, 3 to the 8th, 3 to the 12th, 3 to the 16th would all be this bottom row. So 3 to the 17th, 3 to the 18th would then be the second row. It should be 9. Yep. trying to figure this out. Seto, I'm going to have to take a look at that at break. That's maybe too involved for me to do on the spot right now. Let me just check it out at break. All right, a couple more flashcards. When you see the phrase translate x subtracted from y, we need to remember that 3 subtracted from 4 does not equal -1. Right? 3 subtracted from 4 means start with 4 and take from it 3. Right? Make it like a real life problem. You have 4 apples. So take 3 of those apples away from 4. Now you have 1. So we don't want to confuse x subtracted from y with y subtracted from x. So this would be a really good flashcard to say, oh yes, it means y minus x, not x minus y. Yes, you can certainly see remainder problems when you don't divide by 10, but those won't be based on the units digits. Yeah. Yeah. All right. I think we've flashcarded out this problem. I've got another problem that came in. Kieran, is she here? Maybe not. Kieran suggested this one. I know I had a handful of people want to look at some data efficiency stuff. So let me go ahead and give you a couple minutes to think through this while I answer some questions in chat. It's been 120. It's been almost 2 minutes here. Sorry, I'm still scrolling through chat. All right, so this one asks us about which franchise. I kind of tweaked Kieran's original question and made it a little bit different, so I wasn't just completely taking another question. Did franchise X earn a greater profit than franchise Y last month? Because whenever we see profit, and this does not just go for quant, this goes for like critical reasoning too, because a lot of critical reasoning problems are based on profit and revenue and cost and expenses and income and all of these things. When we see profit, we must remember that profit is a combination of revenue and cost. Okay. And so using that information, we can look at statement one and say, well, statement one tells us about relative expenses, but I still have no idea about which franchise had more revenue, more income. Okay. So I know like franchise Y comes out ahead in costs, but they could come out ahead in revenue. They could come out way behind in revenue. So we're gonna say statement one is not sufficient because again, we need revenue and cost info, and it only gives us cost info. So we're gonna get rid of statements or statement one being sufficient. So answer choices A and D have to get out of here. Similarly, statement two, right? Statement two gives us revenue values, right? Or at least relative comparisons here. Franchise X made more money in revenue than franchise Y did. Okay, but what about franchise X's or franchise X and franchise Y's costs, right? I know franchise X has an advantage in revenue. I do not know who has the advantage in expenses or cost. So statement two is similarly not sufficient. So we've gotten rid of A, B, and D, and I think this is where this problem, has its difficulty, is in taking a look at both statements combined and saying, I've got expense info, I've got revenue info, this should be enough. And we want to kind of think about that a little more. Here's what I know when I combine these. Let me just go ahead and white box the whole thing here. When I combine these statements, I'm typing in whites. It's not going to show up very well. When I combine these statements, I know Y has the expense advantage. I know X has the revenue advantage. And now I need to see whose advantage is larger. I know franchise X's advantage is in the amount of $60,000. Do we know the amount of Y's advantage? No, not the specific amount. You only know it as a fraction. Okay. If franchise Y's expenses were like $200,000 and franchise X's expenses were $300,000, well, then neither of them earn a profit, but franchise Y is going to come out ahead. On the other hand, if franchise Y's expenses were $2 and franchise X's expenses were $3, then this advantage of $60,000 in revenue way more than makes up for the $1 difference in expenses, right? And so one way that we could kind of write this out to really prove it is if I'm looking for greater profit, I'm going to try to see does X's rev minus X's cost or expenses outweigh Y's rev minus Y's costs or expenses. And what I know here is I know Y's expenses are 2/3 of X's expenses. So maybe I could just put that in here. And I also know that franchise X's revenue is equal to Y's revenue and 60,000, right? And so maybe I could kind of, I don't know, put that into here and say, look, Y's revenue plus 60,000 minus X expenses, is that greater than Y's revenue minus 2/3 of X's expenses? And now we have two terms that we could combine here. And we could say, look, I could subtract Y's revenue from both sides and leave 60,000 here. And I could add X's expenses to both sides of the inequality and end up with 1/3 of X's expenses here. And now this question is asking, is $60,000 more than 1/3 of X's expenses? And we have no idea. Okay. So what we need to understand from this problem, I think, is twofold. So the answer here is E, unless that, to make sure that's not ambiguous. The answer here is E. We still don't know the answer to this question, even with all of these pieces of information. What we need to get from this, I think, is twofold. One, whenever you see profit, we need to get information about both revenue and cost. And if I could build on this flashcard, it's the idea that whenever we see some information about comparative profit, like which profit was larger, which profit was smaller, I need specifics of both revenue and cost. Or I need to know if the two advantages belong to the same team or franchise, right? If franchise X has the advantage in revenue and the advantage in cost, then I know they made more money in revenue and they spent less money to get it, so their profits have to be larger. Yeah, I think the temptation on that problem is to say, oh, I've got expense information and I have revenue. That should be enough. We need to be able to compare them a little bit more in better detail than that. Good. All right, I've got a couple more. We got a couple more here. One of my favorite problem types was sent to me, and so I made kind of my own example of one. And so I'll give you a couple minutes to think through this one. That's been 1:20. I've gotten a couple answers in. Well, don't call my favorite problem type a nightmare. To be fair, I don't know if this is my favorite problem type. I like it. All right, that's been about 2 minutes and 20 seconds. We'll go ahead and pause it here. Yeah, so these problems often give people a lot of trouble because, well, if you set it up algebraically, I think you might find there's too many variables for how many equations you have. And when you set things up algebraically, I think you kind of obscure things. All right, you obscure things. So what that algebraic approach often looks like is setting up some equations like, okay, we'll call the number of $5 gift cards A and the number of $75 gift cards B. And I know the total value of these adds up to 800. And I'm trying to look for the sum of A and B. Like, what's the sum of all the $5 gift cards and $75 gift cards, the total number of cards? And you're trying to solve for n, and you have 2 equations and 3 unknowns. This seems maybe impossible. So one thing that one thing that we're going to run into difficulty with this problem is we're going to overlook some like pretty important aspects of this problem by creating these equations. All right. The constraint that's in play in this problem that the algebra obscures is that the values for A and B, and therefore n, all have to be non-negative integers. Right? Like you can't have 0 $5 gift cards and 10 2/3 $75 gift cards. But the algebra would say, oh yeah, 10 2/3 is and 0 are values for B and A. Okay, so we know this, right? We know gift cards don't come in like fractional amounts. But it's obscured in the algebra. And this is often the case where like algebra is almost like too powerful of a tool to use, right? The metaphor I like to use is algebra is a tool. It's a very powerful tool and it can be used in a lot of circumstances, but like a chainsaw is a powerful tool and a chainsaw could cut the grass in your yard, but it's probably not the right tool for that. You're just going to hurt yourself. Same goes for algebra. So another way to approach this problem is, in my opinion, this is the way I like to do these, is I just want to set one of the values equal to 0. Right? So I want to just say, what if there were no $75 gift cards? What if they were all $5 gift cards? What would that mean? Well, if there were all $5 gift cards, then 5 goes into 800 a certain number of times. 5 goes into 80 16 times. So 5 goes into 800 160 times. So I might want to just write that out. Okay. I could have $165 gift cards. That would get me to $800. So now I need 0 $75 gift cards. And that, of course, leaves me with 160 total cards. So now I want to incrementally change this. And so what I'm going to do is I'm going to replace a bunch of the $5 gift cards with one of the big gift cards, right? I want to say, what if there were exactly one $75 gift card here? There can't be half of one. There can't be 2/5 of one. There has to be non-negative integer amounts of them. So how many $5 gift cards go into a $75 gift card? Yeah, 15. So if you exchange 15 $5 gift cards, you can get a $75 gift card. So now you only have 145 of these left. It's still a lot of gift cards. The total number of cards now is not 145, it's 146. Yes, you've exchanged 15 $5 cards, but you've gotten one special card back. So that is a net change of 14 fewer cards. So this pattern should repeat. If you put a second $75 gift card there, you will again subtract 15 cards here to get to 130. And now that leaves you with 132 gift cards total. And that is the only possible answer of the ones on the board. It's very easy to pick answer C here, right? Because you're kind of focused on this. Oh, I just trade in 15, I trade in 15. Remember, you're getting a card back each time. Right? And so that is the trap here. Yeah, it is a very easy trap to fall into. So, I mean, we just got to learn our lesson from it. So here's something I might include on a gift card, on a flashcard, the $75 flashcard. When I have to think about how many, whenever a word problem asks me how many, or total number, which is what this problem is asking, how many gift cards were there total, basically. Remember, when you're counting how many, non-negative integers only. And remember that algebra often obscures that constraint. So then you could try creating your own problem like this. So one problem that I just kind of came up with was this, like how could only quarters and dimes, that is 25-cent pieces and 10-cent pieces, add up to $2.50? As we just kind of think about what we just did with those gift cards, like what are some options here? What I would do is I would either set the number of dimes to 0 and figure out how many quarters there would be, or vice versa, set the number of quarters to 0 and figure out how many dimes it would take to get to 250. So there could be 10 quarters and no dimes, and then say, well, if I trade in 2 quarters, I can get 5 dimes back. You can't trade in 1 quarter, because then that would create 2.5 dimes for change. And again, 2.5 is not a non-negative integer. So, and you'll see there's only so many ways to do it, right? There's 10 quarters, 8 quarters, 6 quarters, the 4-quarter method, the 2-quarter method, and the no quarter all dime method. There's only 6 ways to do it. And it seems like the algebra would show you there's infinite solutions, but the algebra doesn't know about integer constraints. All right, we're going to do one more, and then I'm going to walk you through a program that uses this. Go ahead and take, I'll give you 2 minutes for this one. I'm going to spoil this for some of you. The answer is not 1 or 2. Read carefully. If you sent me a number other than 1 or 2, I'll give you the virtual thumbs up. Yes. It's been just over 2 minutes. I'll give you a little bit more time as I'm answering some questions here. All right. All right, so good discussion happening in chat here. Here's what we need to do on this problem. X squared is divisible by 216. 216 is kind of a hefty number, right? So we know already that x squared is at least 216. I guess technically like x squared could be 0 because 0 is divisible by everything. But if x squared were 0, then x itself would not be positive. So that kind of rules out 0. So now this tells us x squared is at least 216. And that kind of then gives you some values, restraints on x itself. Now this problem comes from one of our strategy guides, and there are not answer choices included in it. If there were answers, I think what you'd want to do is if you didn't have any other idea what to do, you'd just test them out, like test out what x could be. Could x be one of these choices, and then see what happens. But we don't have any answer choices, so this is more of a theory-based question. In order for x to be divisible by 216, what that means is all of the factors themselves of 216 can be found within x squared. Okay, so what I'm going to do is I'm going to create a little factor box for x squared. And what I'm going to say is I know 216 is part of x squared. And that means all the little building blocks of 216 are parts of x squared. 216 is a number you might see on the Gmat. 217 is probably not a number you'll see on the Gmat. What is 216? Yes, 216. This is maybe worth a flashcard. 216 equals 6 cubed. And so what I know here is that within x squared, I know I have 3 factors of 6 and, potentially other things. What I want to do, though, is I want to break down the factors into as small of pieces as I can. And so every 6 is made up of a 2 and a 3. And that means I know there are 3 factors of 2 in x squared and 3 factors of 3 in x squared, because this is the prerequisite to be divisible by 216. Now, it's possible that x squared is divisible by other things. Maybe I'll just kind of put that in another color here. Potentially other integers as well could be factors of x squared, but we are guaranteed the factors in blue. All right, so what that means is x itself needs to have half of the factors that are in x squared, right? X squared can be split evenly into x and x. And so kind of one way to think about this is like within the whole box of x squared, we have 2 pieces, 2 representations of x. In order to make x the smallest thing possible, I need to find 3 2s and 3 3s in here. And I want to minimize the other integers that are a part of x. So one thing you could try doing is saying, oh, maybe there's 3 2s in this x and 3 3s in this x. The problem with that is these x's are not the same, right? X should be equal to x. And so this x cannot be 2 cubed and this x be 3 cubed because they're not the same. So what you'd have to do at this point is add other factors so that everything in the left box is the same as everything in the right box. And now x has gotten, I don't know, kind of large. It's not as efficient as it could have been. So what could be another way to distribute these blue 2s and 3s into these x's here? The way that's going to be most efficient is to try doing something like this. Maybe I'll just keep that in ascending order. And I have combined 3 2s and 3 3s. So I've checked all of these requirements off the list, but now the x's aren't the same. And so now I need to supplement from my potentially other integers so that I can get the 2 x's to be identical. This one has 2 factors of 2, so I'm missing one here. This one has 2 factors of 3, so I'm missing one here. And now the 2 x's are equivalent. This is as frugal as you can be with these other integers. That allows x to be an integer itself. And so that means here, x would have to equal 2 times 2, which is 4, times 3, which is 12, times 3, which is 36. That's as small as x can be. Yeah, a trap for reading this problem is thinking that 216 is divisible by x squared. And if 216 is divisible by x squared, then yeah, the smallest thing that x could be here is 1. But we have to make sure we get the direction correct in divisibility and subtraction, right? And multiplication and addition doesn't matter which way you multiply, right? Multiplication and addition are what commutative. Doesn't matter the order, what you do first. But in division and subtraction, it's really important. So some potential note cards here. If n is divisible by 18, what do we know about n? N is divisible by all the pieces of 18, all the factors. That would include 1, 2, 3, 6, 9, and of course 18. 216, when you see this, this is a reasonably common enough number on the GMAT that when you see it, you should know, this is gonna have to do with 6 cubed, right? If you roll 3 dice, what's the chance that all 3 of them show 6? 216, right? Because you have a 1/6, it's 1 out of 216. You have a 1/6 chance for each of them. Yes, JD, that is correct. Let's test the concept we just worked on in this last problem. If x squared is divisible by 9, what do you know about integer x? X must be divisible by 3. Absolutely, has to be divisible by 3. Awesome, awesome stuff. All right, next level. If p squared is divisible by 18, what do we know about integer p? This is where you would want to create those charts. And what you'd say is, what you'd find is p has to be divisible by 6. Yes, each p must have a 2 and a 3 in it because 18 has a 2 and a couple of 3s. Those have to come from the p's. Awesome stuff. I'm going to go ahead and say this. I know we're already at the hour mark. I'm going to show you guys how to maybe use or create your own flashcards in an app. All right. And then I have an additional question that I probably won't include in the video for YouTube because it was very, very involved. And I did promise someone I would talk about it. And then I got to the point and I was like, this probably isn't going to be a good video question, but it has caused me to think about what to do in future sessions. And so I think I will have a future session on standard deviation in the next month or 2. All right, I want to talk about this one program that I've been using called Anki, A-N-K-I. I don't know if it's called Anki or Anki, but I've been using it recently because I'm trying to get better at Spanish. I just want to drill vocab. And so I thought it might be helpful to kind of show you what this app looks like. And so what I've done is I've got a couple decks here. One on Spanish vocab and phrases, but I have one from today on our Gmat Quant stuff. All right. And so one of the things I really like about this program, and there's lots of other programs like it, there's Memrise, there's Quizlet, lots of other programs like it. But some of the things I like about this program are that 1, it's free. 2, it's really simple, easy to create questions and edit them. And you could just like take screenshots of things you want to test yourself on and drop them in. Okay. And it also has this feature of spaced repetition. That is like, as you get questions or as you get flashcards correct, as you know them, it puts them further in the future. And this idea of spaced repetition is sometimes referred to as the Leitner Method, based on a scientist in the 70s who found that like spaced repetition when learning something is like the best way to ensure that we remember for long periods of time. And so Anki has that built in. Okay, so I'm going to walk you through. This is going to be embarrassing because I'm going to get a bunch of these wrong probably. But I'm going to walk you through what it looks like in my Spanish vocab and phrases, and I'm going to show you what it looks like in the quant deck that we just did. So if I want to study, there's 45 cards I'm supposed to look at today. And so I see this verb and I would say, I think this means to enter, though I'm not 100% sure. And now I have the option for like how far in the future I want to look at it again. If I missed it, I'd probably say I want to do this pretty quickly. I want to do this again. If this is a question I'm never going to miss ever, like this is so easy, why is this even in the deck? I'll click easy and it'll put it further out in the future. If I said, this was like pretty tough, I really struggled to get it right, I'll probably click the hard button. And if it's like, exactly right, the Goldilocks version, I'll click good. And based on how many times I've seen this flashcard, these periods of test will change. Okay, so el cielo, that is the sky, right? And so if I think I'm never going to miss this one, for some reason I know this, I'll say easy, and then now it will be a long time before I see that one again. Suppose I got this wrong. Suppose I thought, oh, this is like comprar, which is to buy, cumplir, to buy. I missed it. And so what I could do then is say, oh, it comes to the top of the deck. I'm going to do it again in a very short amount of time. Okay. So we're going to do this for the quant deck that we just made. And I made all these cards earlier today, so they're all ready for review. And there's a couple other ones in here. Okay. So some of these are from a while ago. What I want to do is if I see n squared is equal to 36, I'm going to say, oh, that means n could be 6, or it could be -6. And I really want to make sure I don't forget the negative option because this is something that happens a lot. If you think something's wrong with the card, you just click the edit button and it opens up the window for what the card looks like. And you can make colors, you can edit it here if there's a typo, if there's something that's wrong, if you want to change it. If I want to change this card to being something different, I can do that. I can do that as well. Maybe I'll always remember n squared is 36, so 6 and -6. Okay. So that one was good, put it in the future. If I see absolute value questions in data sufficiency, what am I going to do? What does that tell me to do? It tells me that I probably need to test both positive and negative values. Okay. What about when x and y are integers and xy is odd? What does that tell you? This would tell me that both x and y have to be odd. And if you said, oh, one must be odd and one must be even, then we'll want to drill this again. So maybe we get this wrong. And we say, I'm going to put that to be reviewed very, very shortly. Yeah, if you want to create geometry flashcards, what you can do is, so again, you can browse the decks. So this is Gmat Quant. I have a handful of these, right? So different bases and exponents. What I can do is I can edit them and I can just drag in an image and put it here. Yeah, you can just drag in an image and put it there. All right, back to the quiz. I want to do some more of these that we did today. All right, different bases and exponents in equation. We didn't do that one today, but I'll find a common base. This is an example of that. So we learned the theory, put it into practice. Okay, 60% as a fraction is what? This is from today. It's 3/5, right? And if this is something that you're never going to forget, click easy. If it's something that you're like, I struggled on that a little bit, maybe I'll just choose to review it in a medium amount of time later today. And if it's something I need to drill immediately, it'll put it like a few cards back in the deck. Okay. This is when we just missed, right? And so since I hit do again, it said, okay, we're going to do this in a very short amount of time. Maybe here you realize, oh, this tells me x and y are both odd. You say, that's good. I'll drill it again in about 10 minutes, right? And so this is like a really good tool. It'll capture stats on how you're doing. Again, really easy to add cards, to revise them, to change them. And it's probably a really good resource that, based on how easy it is to create, it's definitely worth your time to do. So that is Anki. That's what I'm using to get better at Spanish. One of my goals in 2021 was to resume studying Spanish, and this app is helping me do it. So I hope it helps you guys too, if you want to make use of it. Yeah, question came in about verbal flashcards. I think I'm going to do that probably in a month. Although I think I have an event in February. Maybe I'll do verbal flashcards then. I think verbal flashcards are best for sentence correction, just because those are the questions you want to, those are the problems you want to see something and know how to react pretty quickly. Yeah. Good stuff. All right, so what I'm going to do here is I am going to go ahead and stop the video. This ends the proper part of the lesson. So I'll go ahead and stop the video here. But if you have questions and you're in the live audience, feel free to stick around. Thanks so much for watching. If you're watching on YouTube, very much appreciate it.